In case of electromagnetic waves, there are the two waves. One is the electric field, the wave associated with the electric field. Second one, the wave associated with the magnetic field. The wave associated with electric field is vibrating along y direction, and the wave associated with magnetic field is vibrating along z direction, and the resultant wave due to the electric field and magnetic field moves along x direction. So this is the direction of propagation of electromagnetic waves. Repeat once again. If electric field is vibrating along y direction and magnetic field vibrating along z direction, then the resulting electromagnetic wave propagates along x direction. One point about electromagnetic waves, that electromagnetic wave can travel through vacuum. Electromagnetic waves can travel through space where no material is present. So electromagnetic waves can travel from one planet to another planet, from sun to earth to sun, without any material medium. So electromagnetic waves do not require any material medium for their propagation. Therefore, electromagnetic waves are non-mechanical waves. In case of electromagnetic waves, both electric field and magnetic field are vibrating, and their vibration is transfer in nature. So this is the electric field along y direction, and the magnetic field is vibrating along z direction, and both are transverse in nature. Here, the wave is propagating along x direction, and the particles are vibrating along yz plane. This is nothing but the basic requirement to develop transfer wave. Since both the things are true here, that is, particles are vibrating along yz plane and the wave is propagating along x direction, therefore electromagnetic waves are transverse in nature. Let us revise a little bit about the equation of transverse wave. The equation of transfer wave is given by this general expression: x equals to a sin omega t plus alpha. In this case, the wave is moving along x direction, and the particles of the wave, particles responsible to create wave, they are vibrating along yz plane, and the wave is propagating along x direction. So general expression for wave is given by x equals to a sin omega t plus alpha. In this equation, omega t plus alpha is called phase angle, alpha is called initial phase, it is also called as a phase constant, and t is the instantaneous time, and a is nothing but amplitude of the wave. As I said you, in electromagnetic waves, there are the two waves. One is a wave created by electric field, and another one, the wave created by magnetic field. So this is the wave created by magnetic field. There are the two waves. One is electrical wave, another is a magnetic wave, and both waves are transverse in nature. The equation of electric wave, the wave created by electric field, is given by, first of all, its magnitude. The magnitude of electric field is nothing but E naught multiplied by sine of, and here is the phase angle, that is omega t minus kx. Similarly, the equation for transfer wave due to magnetic field is given by B equals to B naught sine omega t minus kx. In this equation, the wave is moving along x direction. So point number one, wave is moving along x direction, and E naught is nothing but magnitude of electrical field vector. It is also called as a amplitude of electric vector, electrical wave, and B naught is nothing but amplitude wave due to magnetic field. So both are amplitudes, and t is small t is nothing but instantaneous time, and lambda is nothing but wavelength, and here is a k. K in this equation is given by 2 pi divided by lambda, where lambda nothing but wavelength of the wave, and here is the omega. This the value of omega is given by omega equals to 2 pi n, where n is nothing but frequency of the wave. So in electromagnetic wave, E equals to E naught sine omega t minus kx, and the expression for magnetic field, our equation for magnetic field is given by B equals to B naught sine omega t minus kx. And just I told you that the value of k is nothing but 2 pi divided by lambda, and the value for omega is nothing but 2 pi n. Now suppose we divide omega divided by k, then it is equals to 2 pi n divided by 2 pi divided by lambda, that is equals to 2 pi n multiplied by lambda divided by 2 pi. 2 pi get cancelled, and we get here n into lambda. But wavelength multiplied by frequency equals to velocity of the wave. Therefore, n lambda is nothing but velocity of the electromagnetic wave. Let us call it by the letter c. Therefore, omega divided by k is nothing but c is nothing but speed of light, that is equals to speed of electromagnetic wave. So electromagnetic waves travel with the speed of light in free space or in vacuum. Since we have here the two equations, now we are going to apply a relationship, that is partial derivative of E with respect to x equals to minus of partial derivative of B with respect to t. This is nothing but something has come from Maxwell and Faraday relation. So we need to find partial derivative of E with respect to x and partial derivative of B with respect to t. Then we will equating them. So we have E equals to E naught sine omega t minus kx. Now differentiating partially with respect to x. So dou E by dou x equals to partial differentiation of E naught sine omega t minus kx with respect to x. This is equals to E naught being constant. So here, and partial derivative of sine omega t minus kx nothing but cos omega t minus kx. Here, then partial derivative of omega t minus kx with respect to x. Here I have applied chain rule of partial derivative. Then E naught as it is, cos omega t minus kx as it is, and partial derivative of omega t with respect to x is 0, and partial derivative of minus kx is minus k, and derivative of x is 1. So that is k dot 1, that is equals to minus k. Therefore, partial derivative of E with respect to x equals to minus E naught k multiplied by cos of omega t minus kx. Call it equation number 3. Since electric field is vibrating along y direction, therefore its symbol y will come. Now we'll take the equation for magnetic field, that is B equals to B naught sine of omega t minus kx. Now we will be partially differentiating it with respect to t. So differentiating partially with respect to t, that is time. So dou b by dou t, and it is along z direction, so suffix z will come here, and partial derivative of b naught sine of omega t minus kx, b naught being constant taken out, and partial derivative of sine omega t minus kx nothing but cos of omega t minus kx. Now partial derivative of omega t minus kx with respect to t. Here we have applied chain rule of partial differentiation. So b naught cos omega t minus kx, and partial derivative of omega t is omega, and partial derivative of minus kx with respect to t is 0. Therefore we get b naught multiplied by omega multiplied by cos of omega t minus kx, that is partial derivative of b with respect to t. Call it equation number 4. From equation 3 and 4 we get k e naught cos omega t minus kx. This is equation number 3 minus, here was the minus, and from equation 4 omega b naught multiplied by cos of omega t minus kx. So we have equated equation 3 and 4 as far as the Maxwell-Faraday relationship. After that, cancelling similar term both sides. So we get here even minus minus get cancelled both sides. So we get here k e naught equals to omega b naught, implies e naught divided by b naught equals to omega divided by k. Now putting the values of omega nothing but 2 pi n, and the k value is nothing but 2 pi divided by lambda. Therefore e naught upon b naught equals to 2 pi n multiplied by lambda divided by 2 pi. Therefore e naught divided by b naught equals to n lambda. Since now both electric and magnetic field are in phase, and replacing the magnitude of electric field E naught by E and replacing magnitude of magnetic field B naught by B, therefore we get the relation E divided by B equals to n multiplied by lambda, that is frequency. N stand for frequency and lambda stand for wavelength. So product of frequency and wavelength is nothing but velocity of light c, speed of wave, that is velocity of light, velocity of electromagnetic wave, E naught B, E divided by B, that is magnitude of electric field divided by magnitude of magnetic field equals to speed of light. So this is the relationship between the magnitudes of electric and magnetic field in case of electromagnetic waves. The magnitude of electric field divided by magnitude of magnetic field equals to speed of light. And this equation is valid as long as the electromagnetic waves are traveling in free space or in vacuum. If they are traveling in a material medium, then speed of electromagnetic waves not equal to speed of light. The electromagnetic waves, when they are traveling in a medium, that depends upon permeability and permittivity of the medium, and this value will change. So this equation is correct as long as the light waves or electromagnetic waves are traveling through free space or through vacuum.